So hello dear students. So this is Dr. Vijaya Babu. So in continuation with the previous lectures what we have done on network analysis. So right, I think in the last video, so I have explained you the concept of applying or the procedure applying the nodal analysis problem. Okay, so any problem if you want to solve to find out the branch currents or else to calculate the nodal voltages, or else if you want to calculate the voltage drop across the resistor, or else you want to calculate the power drop across the resistor. So any such calculations you can follow a standard method, a standard procedure, a standard approach. Okay, so that what I explained it as the nodal analysis, right? So today, so we'll try to go ahead in discussing with the nodal analysis, and also we'll try to solve one problem on the nodal analysis. Yeah, so nodal analysis, actually this is a case 1 problem. So why I am saying this as a case 1 problem? That is because there are no independent sources you are looking in this circuit. Okay, so there are only all are dependent sources. There are 2 voltage sources and 1 current source, and there are 3 resistors. However, there is some combination and they connected together, something like this. So this is a circuit. Okay, so this circuit, the question is you need to calculate the value of Vx and you need to calculate the value of Ix, right? So 2 calculations you have to do. So now I think you can follow different approaches to solve this problem, right? So you can solve using voltage divisions, current divisions, any one of those methods possible, or else you can apply theorems also, so to solve such approach. But our target now is to strictly follow the nodal analysis procedure to solve this problem. So first of all, I think first you try to recollect the procedure what I said in the previous lecture or previous video if you observe. So I have said some important points. Okay, so to solve this. So we'll try to apply all those points on this problem now. So to go ahead. So first one, very important thing. So the first point what I said is identify the number of nodes. Okay, whenever the problem is given, try to identify the number of nodes. So how many nodes are there? So I'll try to show you here. So the black color, so this is one node, this is another node. So the number of nodes are how many? 2 in this problem. Okay, so now what is the second important point that should be followed in the nodal analysis? Among the 2 nodes, one node must be grounded, right? So that means let us consider this node as A and this node as B. I am naming the nodes. Now let us consider this B as a reference node. So reference node meaning is the potential at the point B, consider it as 0 volts, right? So the potential at B you consider it as 0 volts. So next point. So the remaining n minus 1 nodes becomes what? Non-reference nodes. That means node A as non-reference node. So node A as non-reference nodes, and let us assume the voltage at the node A, not the voltage, I'm sorry, it is a potential, right? So at a point you need to consider it as a potential. So the potential at node A you call it as VA. So that is why I am naming the potential at this point as simply VA. So I think 2 points I have done. I have identified the nodes, I have identified the non-reference node, and then I have identified the reference node also, right? So I have named some voltages, so I call it as VA and VB. You try to consider this as 0 volts. Okay, now, so before going ahead, so one important thing you need to consider is you need to fix the branch currents. Okay, so to fix the branch currents, okay, so if you try to see the circuit, you will be having a trouble with Vx comma Ix. You have a trouble with Vx comma Ix. So to go further, okay, compulsory we should try to redraw the circuit by eliminating the required quantities. So that is Vx and Ix are the required quantities. So we try to erase them. Okay, so immediately you will be having a doubt that if you try to erase, so I'm saying that you need to erase, then if you try to erase, what will happen? So nothing will happen. So just try to erase the Vx and Ix. So this will try to avoid you the lot of confusions that are happening in this circuit, right? That means what I'm saying, guys, so try to erase the value of Vx and Ix. So observe clearly. So if I try to erase the value of Vx and Ix, and if I try to redraw the circuit, so this will be something like this. This is 2 volts. So this is 4 volts. And then this is 10 ohms. And it is 2 amperes. Okay. So the resistor values is 1 ohm. So this is 2 ohm. And it is 10 ohm. Already I have mentioned. And this has VA potential. And it has grounded. That means VB is equal to 0 volts potential. Okay. Is it clear? So what I have done, I have redrawn the circuit once again by removing Vx and Ix. Okay, then immediately you'll be having a doubt that actually required quantities are those, so I am eliminating them. So need not to be worried, dear students. So finally once again we'll come back for the calculation of Vx and Ix. So that means why I have drawn this circuit something like this by removing that Vx and Ix is, so now circuit is in my, I can say, very important control. So circuit is in my control now. Okay, because I have erased the unknowns Ix and Vx, right? So now I'll try to go ahead. Now we'll try to apply the procedure on this problem. So okay, so I'm going ahead. So what is the fourth point in the nodal analysis? Compulsory you need to fix the branch currents. So you need to fix the branch currents means, see here, try to observe. So this branch current, take it as I1. This branch current, take it as I2. And this branch current, take it as I3. I3, right? Now, if you keenly observe, there is a current source in one branch, right? So if there is a current source 2 amperes in one branch, okay, so I think don't consider the branch current as I3. Okay, so to make this problem very simple. Okay, so what I try to do, I try to consider this current as 2 amperes. I try to take that advantage because the branch is connected with a current source. Irrespective of anything in the circuit, always in that branch the current is fixed to 2 amperes because it is an independent source. So it does not depend upon anything. So continuously it will try to generate it will try to generate what? 2 ampere current. So that is always coming out of the source. So that is why this current you try to choose it as how much? So 2 amperes. Okay, don't take I3. Even though if you follow the procedure, if you take I3 and go ahead, you need not to be worried. You'll be getting I3 is equal to minus 2 amperes. If I took a right side direction of this I3. Okay, so that is also possible. But why to worry with one more unknown I3? Because there is a current source given in this branch. So take that advantage. Try to take that current as directly 2 amperes. So now going ahead. Next important thing is just you need to apply KCL at node A. Okay, so this is the fifth point in the nodal analysis. Okay, once you fix the branch currents, then you need to apply the KCL. And one more thing I am saying, wherever at what may be the step you are in the problem, okay, once you fix the branch current direction, until the solution is arrived, you should not touch the direction of the branch currents. That means the currents I1 and I2 I have given, right? So I1, I2 currents direction what I have mentioned, right? The same direction should be fixed until you arrive at the solution. You should not change the direction of I1 and I2 because now we are going ahead for the KCLs by considering the directions of I1 and I2. If you try to change them at the middle of the problem, then compulsory the problem goes wrong. So this is a precaution compulsory you have to take in case of I1 and I2. Right. So now applying KCL at node 1. So it is very easy applying KCL, right? So entering currents is equal to leaving currents, right? So entering currents is equal to leaving currents. So that means I can say if you try to stand at node A, you stand at node A, then you need to observe what are the currents coming in and what are the currents going out. So keeping that in mind, so entering current I1 entering plus 2 ampere is also entering this way, I1 is entering this way, but I2 is leaving the node A. So it is going down, right? So that is I2 is a leaving current. Okay, now I have applied the KCL at node A. So what is the next step? I said the last step I said is what? You need to apply the Ohm's law now. I think in the last video we have done lot of logics how to apply Ohm's law for a given problem. So how can you write the value of I1 now? So the value of I1 you can simply write it as this end voltage. So this end voltage with respect to ground is or potential is how much? 4 volts. Okay, this end potential is how much? VA. So I1 value is 4 minus VA divided by resistor 1 ohm. Okay, plus 2 is equal to the value of I2. So the value of I2 is this end potential is VA minus this end potential is means this potential with respect to ground. This potential with respect to ground is how much? It is minus 2. So you should be very careful about it, right? That means it is minus 2. Okay, so and it is divided by 2. So that means 4 minus VA plus 2 equal to VA, okay, plus 2 divided by 2. Okay, so if you try to solve this, so you'll be getting the value of VA as VA, if you try to upon solving, you'll be getting it as simply 10 by 3 volts. This is how much? 10 by 3 volts. Okay, so once you got this nodal voltage, okay, now you go back to the problem now. So what is the problem? The problem is the calculation of Vx and Ix, right? So calculation of Vx and Ix, now you need to observe. So where is Vx and where is Ix? Okay, so I'll try to go ahead for the calculation of Vx. So now Vx is equal to, okay, so directly here the current entering the negative terminal of Vx, that is how much? 2 amperes. So from the Ohm's law usually Vx equal to IR concept. Okay, that means resistance is 10 but the current is entering the negative terminal na? So that is why you need to consider minus 2. So the answer is minus 20 volts. That means in the calculation of Vx, actually the nodal voltage VA is not at all required for us. Okay, directly you can calculate because you have given with the current source, right? Directly you have the current source and you can apply the Ohm's law across 10 ohms resistor. So directly you will be getting the value of Vx as something minus 20 volts. Now going ahead for the calculation of Ix. So for Ix, compulsory you should know the potential at the point here, that is VA. So this VA calculation is required. So how can you write Ix now? So it is simply VA minus, okay, that potential is minus 2 volts divided by the resistor is 2. Okay, so that means this is something like VA plus 2 by 2. I think you know the value of VA. Substitute the value of VA. So VA is exactly equal to 10 by 3. 10 by 3 plus 2 by 2. So the value of Ix, I can write it as simply 10 plus 6 by 6. So 16 by 6 amperes. So this is how you can calculate the unknowns Ix and Vx. So the best thing what I have done is, okay, whenever before starting the problem or before fixing the branch currents, so I have erased the unknown things, that is I have erased Vx and Ix and I have took the circuit is in my control. Once the circuit is in my control, then I will assign the nodal voltages, I can assign the branch currents and then I can apply the KCL and I can apply the Ohm's law and finally upon solving them I will be getting the nodal voltages. So once you get the nodal voltages, okay, then you go for the problem now. What is being asked in the problem? So you try to observe the problem and what are the unknowns he is asking. So with the help of nodal voltages, Okay, so surely you'll be going to calculate what are the unknowns being asked in the question. Okay, so this is how the procedure of nodal analysis can be applied and how this nodal analysis will help us in solve. So it is a systematic procedure how it helps us in solving the problems of networks, right? So I'd like to thank you for giving this opportunity. So in the next lectures we'll try to go ahead. This is a simple node problem what I have took. So in the next video we'll try to consider a problem with two nodes, a little bit complex. Here I got only one equation, right? So two nodes means you'll be getting two equations. Upon solving them you'll be getting the two nodal voltages. So that problems we'll try to go ahead in the next lecture. So thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.